An energy pie chart will tell us when we have a fixed amount of energy, how that energy is distributed among the various types or forms of energy. This will give some numbers to our energy skate park pie diagrams, and we saw the skater going up and down inside that half pipe. And in this example, we can see we have a 60 kilogram gymnast drops from bars that are a height of 4 meters high. Calculate the gravitational potential energy, kinetic energy, and total energy, and then velocity at various points. Let's take a look at that. And just remember, how did that gymnast initially get that energy? There was some work done to the gymnast. Perhaps they were picked up and placed on those bars. Let's take a look at the various energies we have here. We see that our gymnast is at a zero velocity on that at the top of the bar. So we know that the gymnast will have zero kinetic energy at that point. And then we have the statement here that there's no dissipated energy. That would be the same in our skate park when we set our friction down to zero. So let's take a look at our gravitational potential energy, and we know we can figure that out by looking at the mass of the object times gravity times the height. In this case, we have the mass of our gymnast is 60 kilograms. Gravity is 10 newtons per kilogram. Okay, a little squeezed here, and the height is 4 meters. And I see when I multiply 60 times 10 times 4, 2,400 joules. That's the only form of energy we see here, so our total energy is 2,400 joules. And in a pie chart, we can label that our energy, potential, gravitational. The entire pie is due to gravitational potential energy. Halfway to the ground, let's take a look at what our gymnast's energy is. One, we see that our total energy stays the same. We've done no work to this. That is an assumption. We've been given this, that there's no dissipated energy, and let's see how we end up doing this now. Okay. Halfway to the ground. If we're halfway to the ground, we would only have half as much gravitational potential energy as we had before. So half of 2,400 is going to be 1,200 joules. When we add up the three forms of energy, our gravitational potential, our kinetic, and our dissipated, we need to add up to our total energy. We see that there's no dissipated energy. I think we can see that we have 1,200 joules of kinetic energy. So remember, our total energy is equal to all of the energy in our system. Take a look at our pie chart. We know that half of this is our potential gravitational energy, the other half is our kinetic energy. Let's figure out the velocity. We know that kinetic energy is equal to 1/2 mass times velocity squared. We have a mass and we have the kinetic energy. Let's see if we can figure out velocity. So I've replaced my kinetic energy with its value, 1,200 joules. I've replaced my mass with the 60 kilograms listed in the problem. So it seems that some of you are finding it easier to put the numbers in earlier. The normal scientific way is to use symbols all the way through and then plug the numbers in at the end, but I'll do it this method because it does seem to help many of you. So I've rearranged this so velocity squared is equal to 2 times the 1,200 joules divided by our 60 kilograms. But remember, we're looking for velocity, not velocity squared, so we'll need to take the square root of both those sides. Let's do a little math with that. So I see this is the square root of 40 meters per second. Let's see, 40 meters squared per second squared. That's equal to, and that's square root of 40. I'll get 6.3 meters per second. You math types will probably say, yes, it's actually plus or minus 6.3 meters per second. You're correct. It could be going to the right or to the left. Right now, we'll just take the positive root. Let's take a look at this last situation. Okay, it's right before it hits the ground. Okay, and let's take a look at the total energy. We've done no work to it. We've taken nothing out of it, so we still have 2,400 joules. We now end up having the case where the height is 0, so we know there's going to be 0 gravitational potential energy. So all of the energy that's available here is kinetic. 2,400 joules. so that we know that all of the energy is kinetic energy. Let's briefly figure out what the velocity would be of the kinetic energy is 2,400 joules. Anyway, I take the square root of all that. It's the same form we see up here. I get 8.9 meters per second. It's kind of interesting that the kinetic energy has doubled, but our velocity has not. Why is that? Because of that squared term. That if we were to double the velocity, we actually increase our energy by 4 times. If our velocity goes up by 3 times, our energy goes up by 9 times.